Hello and welcome to lesson 2. And on the lesson 2, we are going to cover switching. We have got three main topics here, and all the topics will be covered by real-time labs. Lab 3 will be based on VLAN, VLAN trunking, SVI, and also I will show you how to enable the DHCP on a switch or on a layer 3 switch rather. Lab 4 will be about spanning tree protocol, and we will check there how and why we need STP and what is the process to elect a root bridge, root port, and so on. And finally, your lab 5 will be about Etherchannel, and we will see that what is the disadvantage of STP and how do we overcome that with the help of Etherchannel. So let's dive in. All right, so let's dive into our switch lab. Will be interesting lab. Let me just first of all create the topology, and then I will explain what is the topology about and what we are trying to achieve. So let me pull out two L3 switches this time, 3500 series. Let me get some end user laptops. I will take 4 each for each of the switches. And let me do the connectivity. F01, 2, 3, and F04, right? Similarly, F01, 2. One not so good thing about packet tracer is that the interfaces, when it shows up, it's pretty nudgy and noisy. You probably have to just make sure that you remember the interfaces. If it's a very complex kind of diagram, just note it down in a notepad, and that's the way to actually ensure that you know the interfaces. But the good thing is that it comes in a sequence. So if you have got F0, 1, 2, 3, 4, the top one is 5. Okay. All right. Almost there. Okay. Now let me explain what we are trying to do. Let's say that on the left hand side, the switch 1 is having 4 end users connected, and switch 2 on a separate branch office, like branch office B, and the switch 1 is on branch office A. On a separate branch office B is having 4 end users connected. Okay. Now let me just label the IP address and the VLANs, and then we'll talk about what is exactly the topology about. So IP address can be 10.1, I will say. This is 10.2. This is, let's keep it 20.1, and let's keep it 20.2. Okay. Similarly, we can keep it 10.1.13. We will keep it 10.4. This is 20.3, and this is 20.4. Okay. Now VLANs, I will just make these two 10.1 and 2 as VLAN 10, assign them to VLAN 10 and give a name there. Let's say sales. And this one I will also make a VLAN 20 for 21 and 2, and I will make them HR as a name. Okay. Similarly, 10.3 and 4, I will give a VLAN, let's say 10 again, and I'll give it sales. And this one also, I will say VLAN 20 and give it HR. So what we are saying here is that you have got two branch offices, branch office A and B, and each of them are having one switch each, which are interconnected. Okay, and you have got VLANs which are established on the branch offices like VLAN 10 and 20, and each of the VLANs you are having user groups which are attached, like the sales team is connected to VLAN 10 on branch office A, and in branch office B, and the HR team is connected to VLAN 20 in branch office A and in branch office B, right? Now, what exactly is VLAN? VLAN means virtual LAN. So VLAN actually means that when you are breaking your switch into multiple logical broadcast groups. So we all know that a switch has got one broadcast domain, but when it's a VLAN based, like you are logically grouping the switch into multiple VLANs, then we can say that a switch is having multiple logical broadcast domains. The benefit of the VLAN is that number one, the end users can be grouped like together into each of the VLAN as each of the teams. Okay, the traffic management is easier. Okay, and if there is any kind of troubleshooting to be done, let's say multiple users in VLAN 10 say that they have got some problem, you don't have to go ahead and troubleshoot the entire switch because the problem will be lying in the VLAN 10 itself if all the other VLANs work fine. Okay, so that's the kind of the basic about VLAN. Now, what we are trying to achieve is that the person who is sitting in the 10.1.1, okay, he should be able to maintain or establish the connectivity between all the devices in branch A office and branch B office, which means that 10.1.1 should be able to establish the connectivity with 10.2, which is in the same VLAN in the same branch office, and 10.3, which is in the same VLAN but different branch office. Similarly, the 10.1.1 should be able to establish the connection with 20.1, which is in a different VLAN in the same branch office, and 20.3 and 4, which is in the same the similar kind of VLAN like 20 in a different branch office. So this connectivity also is called inter VLAN routing, because the VLAN 10 user will be able to not only talk with the VLAN 10 in the same branch but in the different branch, and with the end users of the other VLAN in the same or the different branch. So let's move step by step. On the left hand side, you will see the steps I have written down here, which we'll go through one by one to establish the final logic, which we want to say that the 10.1 should be able to connect or ping to all the devices successfully. Our first two steps are VLAN creation and VLAN implementation. So let's perform those two steps and then we will slowly get down. So let me go to switch. This is our command line interface. And that is the screen which you see when you go into the Cisco IOS switch. Would you like to enter the initial configuration dialog? Say no to this, otherwise it will take you through a wizard. Press return to get started, press enter and press enable, or just type in EN shortcut and you get into the show command mode of the switch, which means that you will not be able to do any configuration changes from this layer or model or the mode. You will just be able to execute the show commands to verify, right? Now, if I want to do the configuration changes, I will go to config T or configuration terminal and I enter the config T mode of the switch, which is the configuration mode. So first thing first, I will just change quickly the host name of the switch. You don't have to type in the entire command. If you know even the first part of it or a little bit of it correctly, just type that, like say host and press tab, the entire command will be showing up. You don't even have to press the tab. You just keep on typing after host if you know the command well. This is so this is just for the the clear way to get the commands, and I'm trying to show you how to get into the proper command. So host name, to have the clarity, I will say SW1, just to have no kind of ambiguity in the future. So on this, I am going to create your VLAN 10. That's a creation. So VLAN, I will say 10, and the name is sales, right? That's it. Your VLAN 10 is created with the name sales. Easy, right? VLAN 20, I will say enter, and I will say name is HR. Done. Now, how do I verify how these are being created? I can also use the show commands in the configuration mode. All I have to do is that use the do keyword in front of the show commands. So I will say do show VLAN, and you will see the VLANs are coming up, and my 10 and 20 is showing right up here, which means that the VLANs are created along with the names sales and HR. Now, what is this VLAN 1 on the top? The VLAN 1 on the top is called VLAN 1 or the native VLAN, which is basically by default the VLAN which pre-exists in a switch. So once you turn on the switch, the native VLAN or the management VLAN will always be there, and that will be flooding through all the ports from F01 till the last port itself, like 24th port, and that will be by default on the switches, right? Now, this is the creation of the VLANs. Our next step is about implementation of the VLAN, right? Which is showing right here. So, so that step means that now that I have created the VLANs, I need to make sure that they are assigned to the proper interface of the switch. So basically, your switch is here, and interface 1 and 2 are for VLAN 10, 3 and 4 are for VLAN 20. So whatever device you connect to 1 and 2, they will always belong to VLAN 10, and for 3 and 4, if you connect the laptops, they will be a part of VLAN 20. So that part is called implementation, when I want to associate the interfaces with the correct VLAN. So how do we do that? Very simple. I will go to the interface and I will say range, because I'm going to take both interface 1 and 2 like together in one shot. So range, and I will say F0/1 to 2, which means both ports 1 and 2. Press enter and you have reached the interface. I will say switch port. This is the command, switch port access VLAN 10. Once I type this command and press enter, that means your FS0 port 1 and FS0 port 2, or the interfaces, they are associated with VLAN 10. Similarly, for the port 3 and 4, I can do it right away. Just use the up and down arrow keys on the keyboard to get the previous commands, and I will change what I want to change. I will say 3 to 4, press enter, and switch port access VLAN, this time 20, because 3 and 4, they are associated to VLAN 20. Press enter. Now, how do I verify this? Again, go to do show VLAN and you will see that your 10 and 20 VLANs are created. And now on the right hand side, it clearly shows that FS0, 1 and 2 are part of your sales, which is VLAN 10, and 3 and 4 is part of HR, which is VLAN 20. These are no longer part of the native VLAN. They have been moved from the native VLAN to the VLANs which we wanted. So that's all about your VLAN implementation. I have to do the same on the switch 2. Let's go there and get it done quickly. Again, it is all the same. I just have to ensure that I change the switch name to SW2. So first command, hostname SW2, and you get it. Now, again, you create VLAN 10, name is sales, and VLAN 20, name is HR. Our, sorry, something wrong I did there. VLAN names, okay, VLAN 20. Maybe I typed in the same line. Name is HR. We are done, right? Now I can just confirm that, do show VLAN, and let's see what's going on here. So VLAN 1020 has been created. Now the interface is same. Again, 1 and 2 belongs to VLAN 10, and 3 and 4 belongs to VLAN 20. So let me assign them, which is the implementation of the VLAN. So I will go to interface range F0/324, and I will say switch port access VLAN 20, because 3 to 4 is VLAN 20, right? And you can come down to 1 to 2, 1 to 2, which is switch port access VLAN 10. You can do it any way around, right? So now if I come to do show VLANs, you will see that your VLAN 10 is associated with 1 and 2, and your HR or the VLAN 20 is associated with 3 and 4. Absolutely correct, right? The 20 is with 3 and 4, and 10 is with 1 and 2. So our first step is done, which is basically your creation and implementation of the VLAN. Now, we do not have the DHCP configured yet. We'll do it at the end. So as of now, let me go ahead and give some IP address to the laptops, okay? And check, okay, I will say 10.1.1.1, and I will just make it /24, okay? And I will give the configuration here as well. I probably don't have to give the configs to all the laptops because end of the day I will be using the DHCP and I will show it to you how it comes automatically to all the devices. So this two I will definitely check, and I will also check this one, which is your 20.1. So 20.1.1.1, and you will be getting 255.255.0. Yep. And this side I will be doing 10.3. And lastly, I think I will be doing 20.3, which is 20.1.1.3. And we are okay, done. Now let's check a few things from the command prompt. Let's go there, and first I will try to ping 10.2 from 10.1. So ping 10.1.1.2. That's very simple. These both lie in the same VLAN, which is VLAN 10, and definitely it should ping. Let's see. And it's pinging absolutely correct, right? There is no problem. So 10.1 is connected to 10.2. Good. Now I will try to ping 10.1 to 10.3, which is again in the same VLAN, but in the different branch office B. And the switches are connected by a link, right? So let's see if I try to ping 10.3, what's going on there. And this ping will not work out. And I will tell you why. See, the point is that when you are trying to ping 10.3 from 10.1, it will go through this particular FA05, this particular interface, right? Now, FA05 is basically an access port. So a switch has got two kinds of ports. One is called access port and one is called a trunk port. An access port will only allow VLAN native or VLAN 1. Okay, and a trunk port will allow all the VLANs. Okay, now if I want to make the VLAN 10 pass through FS05, all I can do is that I can go to FS05 interface, INT FS05, and type in there switch port access VLAN 10, which means that the VLAN 10 will be associated with FS05 and your traffic will be flowing. Similar thing I can do on the switch 2 as well, and I can associate the FS05 with VLAN 10, and the ping will work out. However, let's think like this. What happens when you try to ping your 20.3 from 20.1? Again, you have to go to FS05, and again, you have to change or associate the FS05 interface with VLAN 20. And how many times will you do that as you keep on adding different kind of networks? How many times will you go ahead to the VLAN and you keep on adding the VLANs or associate the VLANs with the access port? That is not a scalable solution. So the scalable solution is to have this port as the trunk port. Think of trunk as a thick fat pipeline through which all the VLANs will flow. Okay. Now, once I would like to have the trunking done, I have to do two steps here. One, I have to make sure the trunking is enabled on FS05, this particular port. And two is that I have to convert the access port to trunk port. Now, trunking, it works in two protocols. One is called ISL, which is deprecated, which is not used any longer in CCNA. And the second one is called 802.1q, which is basically your .1q protocol. Okay. Now, .1q is definitely used. So I will show you how to enable trunking on FS05. So let me go there and let me quickly try it out. Okay. So I will go to interface FS05. And what I will do switch port. The beauty of the Cisco iOS is that if you forget any commands or you don't know the next word or statement, you can just type a question mark and it will show it to you. So I see a couple of options there: access mode, non-negotiate, blah, blah. And I will see something called trunk. Okay, set trunking characteristic of the interface. So basically I will say switch port trunk. And after that, I'll be giving out the option called question mark again to check what's there: allowed, encapsulation, and native. We will go for encapsulation. Okay, So I will go to the encapsulation option. And then if I press the question mark, you will see only one protocol is showing, which is .1q, okay, or 802.1q. And I will say .1q and I'm done. Now this is the command which is used to turn on the protocol, trunking protocol on the interface. Press enter. Now I do have got a command to check if the trunking is happening or happened. So I will say do show interface trunk. Press enter, and you will see it's completely blank. Okay, which means that trunking is not yet enabled on FS05. Correct. Now that means that we are yet to perform the second step. The first step was to enable the protocol .1q, and the second step is that to convert the access port to trunk port. How do I do that? I will just go for the first commands again. FS05 I enter, and then the second one is .1q, and the third one is switch port mode trunk. That is the command which you use to ensure that your access port is converted to trunk port. Now, if I go to the do show command of trunking, and it will show you the 802.1q is running there, trunking status is going on, and your VLANs all are allowed 1 till 1005, and the active VLANs 1, 10, and 20 are definitely allowed. Okay, so FS05 port is enabled trunking. Now, if I come back to the diagram, you will see that there's two status. One is like green showing up here, the green light, and one is like amber, which means we have to enable trunking on both sides of the link, and then you will see the trunking will be happening. So I go to switch 2. I do the same steps here. And again, interface is same. So FS05, and I will say switch port, encapsulate, switch port trunk, encapsulation .1q, and switch port mode trunk. Okay, and I will confirm that. Do show interface trunk, and you will see again 802.1q is there, and the trunking is happening on FS05, and you will see your VLAN 1, 10, and 20 are allowed. Great, right? So now this means that now if I try to ping, so now all the VLANs are flowing through FS05, and all the VLAN, the data from the VLAN 10 or 20 will be flowing through this particular port. These are the trunking ports now. Now I will try to establish or check if the ping command works for 10.1.13. And look at that, it's working. Beautiful, which means that the trunking is completely successful, right? So our 3 steps are done. Now the next one is that SVI. Now I will show you an interesting concept. If I try to ping 20.1 from 10, let's see what's going on. Okay. So I will say ping, and I will say 20.1.1.1, enter. And you will see the ping will fail. The connectivity is not there. And why it is, I will tell you right now. See, what's going on is 20.1 is a different network, right? Now, think of it. When we go into the routing lesson, you will get this point very clear. But as of now, know that the moment you try to go to a different network from your own, you need something called a default gateway. Without the default gateway, you will not be able to step into the outside network. Okay, so your LAN can be your home, and the main gate in your home can be the default gateway, which you open and you step out to the street. That street is basically the outside world or the external network or the different network. Okay, now we do not have a default gateway established here. So L3 switches, they give you an opportunity to do that, a mechanism to do that, and that's called SVI, or switch virtual interface. What they allow is that they allow you to create a logical default gateway in the VLAN interface, not on the FS01 or FS02, but on the VLAN interface, a logical default gateway. And if I create that gateway, then only once we press ping 20.1 from 10.1, then 10.1 will say that is not my network. But let me see, where is my main gate? I can go there, and from there I can probably find out what is the next network. So basically, like a router, it works where it knows the input and the exit interface, and the routing table is not there, but it almost acts like a router. So that is one of the benefit of a L3 switch. Now let me show you how to create the SVI. Very, very simple. So I will be setting, and I will this time go to interface, and I will not go to FA01 or 2 or anything. I will just go to the VLANs because I have to create the gateway logically in the VLANs. VLAN 10, I went inside and I will say IP address, and there I will type in the default gateway. So 10.1.1.254, that is my gateway 255.255.255.0, and I'm done. Now that is only for the 10 network. Similarly for the 20 network also, I need to establish a default gateway. And understand this, once I create the SVIs here, then you will be able to reach from 10 to 20, right? So I'll come here and I will say interface VLAN 20, and I will say IP address, and I will just change it 20.1.1.254.0. Those two are my default gateway or the interface on the VLANs or the virtual interface on the switch, correct? Now here is a point. When you go to routing, you will be seeing a command through which we can know which are the routes which are connected or established on that particular router. So I can show you do show interface route. Okay, if you press sorry, there is a okay, there's a mistake there. One second. Do show IP route, not in interface, but do show IP route. And if you type that, you will see it's empty. It's not showing any routing or any kind of IP address connected directly. But we did that right now, right? We went to the interface, VLANs, and we created the IP address as the default gateway, right? So now, if your IP address is not created there and not showing up here, though it is created, then what to do? So here is a trick. Now remember that IP routing is by default turned off in a layer 3 switch. You have to manually turn on the IP routing to establish the L3 and to see the routes. So the command to enable the IP routing on the switch is very simple. You have to go and type in IP routing, press enter, and it's done. Now if you go to do show IP route, you will see all the routes which are connected. And you will see C is connected, and you will see 10 is directly connected, and 20 is directly connected through VLAN 20, and this is through VLAN 10. Right. Now let us see, can I go ahead and ping 20.1 from 10.1? I still cannot do that because in the laptop I have to manually establish the default gateway because the DHCP is not done yet. I'll just type in 10.1.1.254. And if I go to this one, I will just type in there 20.1.1.254. Okay, all done. Now let's come here and try to ping. Ping 20.1. Let's see what's going on. You see that? It's coming up fine, right? We can check it once again. And also you will see it is TTL is 127. It is not 128 because it's going to the next network. Okay, I explained that the TTL in the ping process. So 128 means the same network and 27 means you have to go one hop to reach the next one. That explains, right? It's going from your network to the next network. Now the last one which I want to show here is that, okay, one more thing. Can I connect to 20.1.13? Okay, before that, I would like to establish the DHCP. Okay, so DHCP is something which we are going to have a full-blown lesson in the future. But as of now, just know that we are trying to show you how to enable DHCP on a L3 switch or a router. Okay, but there is a proper client server mode which I will be showing you in a separate lesson. So DHCP on the switch can be done very simply. You will say IP DHCP the command and say pool and give the pool name of the initial VLAN. So VLAN, the first one, sales, right? Enter. Then you will give the network address, which is 10.1.10. and you will see the subnet mask. Done. It also set the default router or the gateway. So 10.1.1254. Done. And similarly, you will do the same for the VLAN 20, where the name was, either you can straight away give like VLAN 20, or you can give the name, which is HR, and you can give the network here, which is 20, and you can give the default router, which is 20. So we are done. And you have to give it only in the switch one, right? So now let's see if the DHCP is working. First one, I will go from static to DHCP. Let's see, it's trying to connect, and we got the entire IP subnet and default gateway, right? Successful. I will do that for all the devices now, quick and simple, and we are getting them one by one. Sometimes in packet tracer, you will see the DHCP is not working fine. All you have to do is try like 2 or 3 times. It will come up soon. Thankfully, it's coming up pretty well, but once in a while, I personally see that it's kind of a little bit slow or doesn't come at the first shot. 20.2, now we are supposed to get 10.3, right? Let's see. We got it. So we have not established the DHCP on this switch, but it flows through the connectivity between switch 1 and 2, right? 10.4, and let's come down. Sorry. We can do it actually from here also, DHCP, and we can do the settings here, default gateway. This is static, we'll make it DHCP. Okay. Right. And the last one is this guy, DHCP. Cool. Now let me try out all the pings which we wanted to do. So let's see. First one is our ping 2, of course, 10.1.1.2. That works. Yes, that works. Now I will be doing now 10.1.3, which is through the trunk. That works. And then I will be doing the 20.1.1, which is going through the SVI. That also works. And I will be doing the 20.1.1.3, which is in the other branch office. And let's see if that works or not. And that works. Okay. And what about the 4? It takes a little bit time in packet tracer, but in real time it will be much faster. Okay. So all of the connectivity works, which is pretty cool. So I hope that you got the entire concepts clear about the VLAN, how to create and how to implement them. Pretty simple and straightforward. What is trunking? What is SVI and how to implement SVI? And finally, how to enable DHCP on a layer 3 switch. The similar steps can be done on a router as well. Thank you very much for watching the lab session. Hope you have a good time. Cheers. Spanning Tree Protocol, or 802.1d. Now, STP is one of the most useful protocols in layer 2. Why? Because it prevents the layer 2 bidirectional broadcast loops or the network storm, which is created by redundant topologies. So let's say that you have got 2 switches and it's being connected by 2 links and both the links are active. Now, eventually after some time, you will see that bidirectional loops will happen between both the switches, and it will create a network broadcast storm, which will make your network down, and all the computers which are connected to your layer 2 switches, they will not be able to connect or communicate with each other. Now, spanning tree protocol is a savior that will ensure that this broadcast storms or loops are not happening in a redundant topology. And that's exactly what we're going to check here, that what spanning tree does and how it does that. Now, in the upcoming lab for the spanning tree protocol, I have shown you, why exactly the broadcast storms happen, what causes them, and what spanning tree does. So also you will find that once I disable the spanning tree protocol at the switches and then I go for a redundant topology, you will see the broadcast terms are happening along with the cause of happening. Now, before the lab, I would like to take you through some theory here. Spanning tree protocol has got a little bit of theory on that. Don't be scared on that. It's very simple. And we really don't have to memorize all the stuff I'm showing on the slide. I know it's a lot of information on this single slide, but once you understand the concept, spanning tree protocol is a very easy one, and you will be having a good grip on that. Okay, so let me just pull up my annotation. And also just one more thing, spanning tree protocol is by default enabled in all the switches these days. So you really don't have to worry as a network engineer that you have to go to a switch and you have to enable the spanning tree protocol, because by default that will be turned on. Okay, now let's say this is our topology. This is switch A and the MAC address is A, which I have defined, switch B, MAC address B, switch C, and the MAC address C. Now, the first question that will come to your mind is that why do we need a topology like this, where there is a chance of having a loop? Why can't we connect these switches A, B, and C in a straight line? Like maybe A is here, B is here, and C is here. Now, the answer is that let's say on your switch C, you have got a server connected. Okay, and if you connect a server to switch C, and if you want to reach from A, then your path is A to C, right? If you want to reach from B, then your path is B, A, and C. Great. Now what happens, let me just show it to you. If your this particular link A and C goes down, if this link goes down for some kind of physical damage or some error, then you will lose the connectivity to the server. All the users who are connected to switch A and switch B, all the end users, they will lose the complete connectivity to the server connected to switch C. Now that is something strictly not desirable by a business. Okay, so what business will want is that a topology where there is a duplicate link, a standby link, okay, a redundant link. The redundancy is achieved if you connect between B and C this particular link. That B and C is actually called the redundant topology link. Now what happens if this link particular drops? It's okay, because you still have the path from A to C like A, B, C, and from B like from B to C. Okay. Now, once you enable the spanning tree protocol on the switches, or once the switches are having the spanning tree protocol and they are turned on, then if at all this link fails, this link will be coming up. Okay, so let me just take you through this, that how long it takes to come up and all the concepts of STP. So if you look at the right hand side, you will find the STP port status. So once the spanning tree protocol is turned on, okay, after that your STP switches will be having different states of port. The first one will be starting with disable. Okay, the second one is the blocking port. Blocking means your frames will not allowed through that port. Okay, the third one is the listening port, and the fourth one is the learning, which a normal switch does, right? Listening, learning, and the last one is forwarding, which means your port is in green held and it's able to pass on the switch frames to the other switch, right? Now let's say your port is in blocking. Then how long will it take for the port to come up from blocking to the forwarding status? 20 plus 15 plus 15, right? Which is 50 seconds, which means if your this link is down, okay, goes down, then your redundant link will be taking 50 seconds to come up, which is from blocking to forwarding port. Okay, now 50 seconds is a big time. Okay, if you talk with your IT operations head, that you know what, once the first link goes down, then we will need like 50 seconds to bring up the second link. Definitely he or she will say a strict no to you, because if it's a critical server, then 50 seconds is a huge time for the communication to be disconnected from all the end users, right? So there are ways and means to make sure that you can compress that 50 seconds to a very less amount. And we are going to check that how to do that in the future. Now, a couple of the commands I'm going to show you in the lab, that will make sure that your 50 seconds is brought back to a lesser time. But the other commands, the important commands, which will work in a trunk mode in the switch or the trunk ports, they will be done in the CCNP level. Okay. In the NA, we are going to talk about the access ports, and then in the NP, we are going to talk about the trunk ports. Okay. So that's about the port states of the STP. Now, if you look into the switches a little bit more, you will see each link I have given a number. What are these numbers? If you look at the chart below, you will see that there is a cost associated with each kind of link. If it's a Ethernet link, then the cost is 100, where the speed is 10 Mbps, right? If it's a fast Ethernet, then your speed will be 100 Mbps, your cost goes to 19. If it's a gig Ethernet, your cost goes to 4 and the speed is 1000 Mbps. Similarly, if it's a 10 gig Ethernet, then your cost goes to 2 if it's a 10,000 Mbps speed. So as the speed goes higher, you will see your cost is going down. Okay. Now, STP has got one feature. It will always prefer the least thing. And you will slowly come to know that in detail once I talk about all the different status of the ports. So one of the things is that STP will always prefer the least cost. And I will come to that soon. Now this cost is like these links are fast Ethernet links. And that's why I have mentioned the cost as 19, 19 and 19, which is basically this guy, 100 Mbps. Okay. Now, let's talk about a few more things. Election process. Now, what is that? Once the STP is enabled, okay, after that, the switches among themselves will decide on two things. Number one, the kind of the switch, and number two, the kind of the port. Now, in STP topology, we have got two kinds of switches. One is called the root switch, and one is called the non-root switch. Root switch is the guy which you can think of as the central switch, or probably if it's a team, then it's the captain, right? So the root switch is the one, the central switch through which the information will flow. Okay. And one switch will be the root switch. The remaining switches will be the NRS or the non-root switches. Now we are going to go through the particular election process of how this election happens. This will be happening completely automatically without any effort from your end. But how this election happens, it's good to know. Okay. So number one is that selection of root bridge, which is basically your root switch. How do we select, or how in STP the root switch will be selected? Now that is based on least bridge ID. So like I said, STP always likes the word least, right? So whichever bridge ID is the least, that will be automatically nominated or given the crown of root switch. Now, what's a bridge ID? A bridge ID is a mix of MAC address and priority. Now here, if you look at the top of the switches, here, let's say there's a number. That number is the priority of the switches in default state. So every switch in STP will be having 32768 as the bridge priority by default. So A switch, B switch, and C switch, they all will be having 32768 as the bridge priority. Okay. Now the bridge priority is a tie, right? So it's same for all the switches. So we are going to look for the second number or the first number called the MAC address. MAC address, I have said the MAC address for these switches are A, B, and C, and A will be the least MAC address, B will be a little higher, and C is the highest. We are going in the ascending order. So looking at the MAC address, the least MAC address will be A, right? So based on the least bridge ID, which basically means that your switch number A, okay, that will be the root switch. Now let me take you through this particular concept in this way. So switch A will be root switch, which I marked here, and switch B and C, they both will be NRS, which is non-root switch. Till here clear? Fine. That means we are done with point number 1, selection of root bridge. Easy. Now, the second one is we have to go and find out what is the port. Now, STP topology will be having 3 kinds of port. Okay, one is called the root port, one is called the designated port, and one is called the non-designated port. Now, this is something, a critical thing which you have to remember. The root port and the designated port. Okay, both these ports will be forwarding, which is this one, which means they both are green in status through which the frames can pass through. So both these ports will be forwarding in nature, and the non-designated port will be blocking, which means that's in block state, and that will be blocked by the STP protocol, and that will be acting like a standby. Now with this concept, like I said, we have to find 3 ports. What are the ports? Root port, designated port, and non-designated port. Now in the point B, you will see we have got, there are 4 rules, A, B, C, D, right? However, you do not have to actually follow all the 4 rules. The rules are given in such a way that if there is a tie on the rule number A, then we go for rule B. If there is a tie on rule B, then we go for rule C. If there is a tie on rule C, then we go for rule D. Okay. Eventually, in most of the cases, your rule A will be enough to let you know which one will be the, or which are the ports there. Your root port is like which one. Okay. So second point is selection of root port. Okay. Now the point A says based on least cost from NRS to RS, which means what is the least cost in the path from a non-root switch to a root switch, like from B to A or from C to A. Okay, and we'll check on that. And it also says one rule that one non-root switch can have one root port only. I know it sounds a little bit like confusing, but I will just share with you once again. So number 1 is that to select or to elect a root port, you have to find out the, or you have to choose the least cost path, which is between a non-root to a root switch, number 1. And also you remember that a non-root switch can only have one, have only one root port. It can't have 2 of them or 3 of them, which means that let's say your switch B is there, it's a non-root switch. The root port can be either this guy or this guy. Similarly in C, your root port can be this guy or this guy, but cannot be both of them. Right? Now looking at this concept, let's find out which one is your root port. So looking at the first option, it says you that based on the least cost. Now least cost, if you look at between B to A, your cost is 19, right? So if your cost is 19 between B to A, I mean that's one path. You can also go from B to A like B, then C, and then A. So BCA is one path and BA is one path. Your BA path is 19. What about your BCA path? Your BCA will be 19 plus 19, which is 38. So definitely your this particular path is the least cost path between NRS and RS. Similarly for C as well, your least cost path. So one path is 19 and the other path will be 19 plus 19. You can go round like CBA and reach A as well. Now this path is 19 plus 19, which is 38. So you have to stick with this path. So your this particular path will be the least cost between NRS and RS. So looking at all this, and since you can have only one root port between 2 ports or 3 ports of a NRS, then which one is the root port? Your root port is this particular point, the upper one, right? Because that's having the least cost path, and that is the port there. Similarly for your switch C, the top port will be the root port. Okay. So you do not have to go through the rule number B, C, D. The B says that if your cost is a tie, then you will go to based on least sender bridge ID, means your sender bridge from where the bridge is sent out, let's say switch B, from there the bridge ID, and the bridge ID is your MAC address plus priority. If that also is a tie, then you go for rule C, which is based on least sender port priority, the priority of the port based from the sender. Again, the least one. And if that also is a tie, then you go for the last one, which is based on least sender port ID. So like I said, normally between A or maximum to B you have to go, and your root port can be selected. So our first two steps are done: selection of root bridge and selection of root port. Right now, then what is the last point here? Selection of designated port. Okay, and once your designated port is being selected, then you will automatically find there is only one port left, and that one port will be your non-designated port. So let's say selection of designated port is based on the segment concept. Now segment is this guy, B and A. This path is a segment. Similarly, A and C is a segment. Your B and C is a segment. So in this particular topology, we have got three segments. It says that selection of designated port based on segment concept, and one segment you need to have one DP. You cannot have a segment blank. Like if this segment one end is a root port, you cannot keep that blank. You need to have one DP in a segment, which makes it simple. So our DP ports will be, let me just mark that, our DP port will be, hold on, yes, the top one right next to A. And if you look at the segment of A and C, then again your DP port will be the top one right next to A, because your bottom one is the RP. So you need to have at least one DP in a segment. Now, what about the bottom one between B and C? Between B and C, we do not have any root port or any other ports. So designated port needs to be only one of them, which means now we have to see that on which of the switch the MAC address is lower. Okay, because we are now going to check out the bridge ID, least bridge ID, or the least bridge ID in this one is your MAC address plus the priority. Your priority is same for B and C, 32768, and your least MAC address will be B. So your designated port in the segment BC will be B port, which is right there. Okay, DP. So that's about all your 3 points. Now the important point, the only port which is left in the topology is your non-designated port, which is basically your blocking port. And which one is that? Of course, our port connected to switch C, right? That is our NDP. And that means it is blocking, which means that this is the particular link which will be kept on standby. And once your the primary link, which is basically A and C, goes down, or let's say your link between A and B goes down, then this link will be active. Okay, that's how it works. And in the upcoming lab, I will show you how exactly does the STP work, and what are the verification commands, and how it goes from how it works between the topology. The last concept is about the rapid STP, or what we call it 802.1W, or we call it RSTP. Now RSTP is the next version of STP. It's the enhanced version of STP. Okay, and RSTP by default is enabled on most of the latest switches. Okay, which means that once the RSTP is by default enabled, you really don't have to worry too much about the commands. So there are a few commands. Like one command is called port fast. If port fast command is given between an access port and a laptop, then the moment the link is shut down and it comes up, the very next second only, without any change in the connectivity, the link will be up. Now that option I have shown in the lab. But when it talks about uplink fast and backbone fast, now these are the commands which are used in the trunk port. Now remember that switches will be having two kinds of port, access port and trunk port. Access port, you use the command called port fast to ensure that the moment your primary link fails, your redundant link will be immediately up and running. Okay, or the moment the link fails, it will be coming back as soon as the link in reality comes back. It will not have to wait for 15 seconds plus 15 seconds, like 30 seconds, right? But in a redundant topology, like in a trunk port, switch to switch or switch to router, what happens? If one link fails, the standby will be coming up, but will be coming up only in 30 seconds, right? Because sorry, in 50 seconds, because it's 20 plus 15 plus 15. Uh, so once again, if the things were not clear in the first go, I know it sounds a little bit confusing. See, in a redundant topology, when there are two links, okay, and one link is in standby and one is active, once the active fails, the standby will be coming up to the active state in 50 seconds. Why? Because from blocking to forwarding, we need 20 plus 15 plus 15, which is 50 seconds. However, if it's an access port link, that will not have the blocking state because there is no redundancy there. You will just connect the port to the computer or laptop. Now that will go through only the delay of the listening and the learning, which is 15 plus 15, which is 30 seconds. That 30 seconds of listening and learning, once the link comes up, okay, that delay can be converted to 0 by using the command called port fast. And in the trunk ports for the switches, the delay can be brought down almost to 0 by using the command uplink fast and backbone fast. Now, uplink fast and the backbone fast are in detail covered in CCNP, not in CCNA level, but just understand that they are for the trunk ports and not for the access ports. Now, in the rapid STP, your election process is similar to the STP. So you don't have to worry about a different kind of election process because it's all the same. You have to select the root bridge and the root port and the designated port and the non-designated port. Okay. So that's all about your spanning tree protocol. See you in the lab of STP. Thank you for watching this. Cheers. All right, so let's start off with the spanning tree protocol lab. So first of all, in the previous slide, we have seen that what exactly is the spanning tree protocol and what is the concept of the root switch and the non-root switch, followed by the different port states, like starting from your blocked and disabled or blocked to learning to listening and learning and to forwarding, right? All I can say is that along with all this stuff, you have got the cost per link and so on, and the sequence of the steps on how to do the election process for the root switch. Uh, what I can say is that the information is too much to handle in one shot, right? So you need to practice a little bit on the spanning tree. If you have got a packet tracer, great. If you don't have, then try to practice probably using some diagrams. But the best way is that the more you practice on this, like probably 3-4 diagrams, it's easy for you to remember and to recall the concept, because spanning tree is pretty easy protocol, but the place where people they flunk a lot is that they try to memorize too much info in one shot, which is not possible. You cannot do that, right? So if you go to the simulation, which is this Cisco packet tracer, which is beautiful, where all the commands will be working, and trust me, if you go to any of the switch and if you want to find out which switch is the root switch and what is the root port and so on, they all can be done with the help of simple commands. But all I would like you to have right now is that a good concrete, a solid concept of STP, and that's why the lab is here. Now, first thing first, I'm going to show you the spanning tree and how it works and why the spanning tree is needed. Okay, without the spanning tree, what's going to happen? And the second part will be about, I will show you how the spanning tree is configured, how do we use the show commands, how do we use the port fast, and so on. So let me start off like quickly and get into this topology, a simple one, where I will just quickly show you how the spanning tree works. So if I take this particular link, fast Ethernet cable, and connect between two switches, we are done, right? And if this is the case of one single cable, then we do not have any chance of loops. correct? So your question might be that why we do not use these kind of designs in the company. Okay, there's all the switch can be connected in a linear fashion, and there will be no loops at all, right? The problem is that when you are trying to work in an enterprise network, okay, or in a business network, then definitely you need to have some kind of standby link. What if this link fails, tomorrow? Then you don't have anything to survive on. You don't have an insurance kind of policy or a standby in the backend, which will say that, that particular link is there. If this falls down, that comes up. You don't have anything, and your entire network goes down. So we don't want that. So in order to come out of that, what we do is that we actually create two links, okay, or sometimes more than two, between two switches or two devices. Now between two switches, if I use two links, which makes it like simple, that one link will be active always and one link will be passive. Now if you look into the link, let me just zoom my screen. If you look at properly, I don't know if you can see all the uh, probably I need to show it like this to show all the colors here. In this way, your packet tracer is not really great if you want to check out all the um, color mechanisms. I think now you can. Yeah. So if you look at both the ends, you will see this part is green, okay, and this is also green, and this is also green, but the top link is up and the bottom link is down because this has got an amber signal. Right now, that exactly what STP does. It makes sure that one of your link is in the blocked state and the one link is in the active state. Okay. Now, why it does that? What if it is not doing that? What if we take off the STP? Then what's going to happen? I will show you. So let me pick up quickly two laptops here and connect them. Fast Ethernet connectivity, FS03, FS03. Just to remind you, if it's a fast Ethernet and 100 Mbps, then the cost per link as per STP will be 19, right? 19. Okay. Now in this one, we are going to put some IP address. Let me quickly just type in some IP here, 1.1.1.1, and take it off. Type in something here, 1.1.1. Oops, 1.2. Okay. Let me assign the IPs quickly. Go to desktop, 1.1.1.1, and this will be 1.1.1.2. Okay, all done. All right. Now let me go ahead and do the first thing is that I will go to the switches and I will disable the STP. Let me go to the first switch, CLI. Okay. Okay. I will just say that no spanning tree VLAN 1. That is the command if you want to deactivate or disable the spanning tree. Now VLAN 1, because now it's only one VLAN. The VLAN 1 is the native one, which is going to run between all the switches. Press enter and you are done. Similarly, I will come to switch 2 and I will say no spanning tree VLAN 1, right? Done. Now my task will be that I will go to this particular laptop and try to ping.1.1.2. Before that, also see that both the links are up and running now. See, all the signals are green, which means both the links are now running. None of the links or none of the ports are blocked. Okay. Before I press enter, I will just go to the simulation mode and try to show you what happens in terms of your ping process, which is again your ICMP plus ARP, right? So I will go to edit filters and choose ARP and ICMP, and we already have done a deep dive lab on that in the lesson 1 itself. So let me just go ahead and press enter and let's see what's going on. So yes, the first one will be your ICMP request, and that will fail because we do not know the destination MAC address yet, and that's why, I mean, the switch will not know that, and the ARP will be triggered. Now, once ARP is triggered, the way it works is that the request packet of ARP will be throwing a broadcast, right? FFFF, correct? 12 Fs. Now, this particular ARP, if you look into this, what's going to happen? Let me pick up a quick annotation. See, this has got two ports here, and this side also has got two ports. So what will happen? The ARP will broadcast on both the ports, correct? And then this will flow to this side. Now, once it is broadcasted to both the ports, then these two ports also, like this switch, have got like one link here, one link, and one more link, like three links. This switch will again broadcast it through all the two ports here, okay, or the three ports here, and it will keep on doing that, and the circle will be happening. So basically, your ARP will be doing a complete huge broadcast and multiple times, because each time it will hit a switch port, the switch port will again broadcast it to the other switch port. It will not realize that it's already being done. Again, since the link is like dual, it will keep on doing that. It will create a network a broadcast storm, L2 dual mode, or a dual storm, and then what's going to happen? Your network will go down. So let me just show it to you. If I just press this forward, you will see it's only ARP. If you look at the right hand side of the simulation, normally ping is like ARP, the request happens, then response happens, and then ICMP again takes over. Without a ICMP, the ping will not get complete, because ICMP will be actually carrying the IP address. It's a layer 3, and without the layer 3 ICMP, we will not be able to completely successfully do the ping command. So since it's only ARP, you will see no ping will happen. All right. And if you go back to your switch now, if you just press enter, you will see nothing is there. It will be request timed out after some time. So that basically means that when you take off the STP from the switches, okay, your ARP will do huge broadcast and will continue doing that. Okay, it will be a layer 2 broadcast, and it will destabilize your MAC table on the switches. It will lead to a complete network down, because the devices will not be able to connect to each other which are connected to the switches, right? You see, request timed out is coming up. So that is why we need the STP protocol, which is on 802.1d, and that's why we say that without STP, we will not be able to go with a redundant network. Okay, so that's the basic. Now let me just take off a new lab here. Okay, now let me show you the other features of STP. Let me pick up some switches. I will pick up some 3460 this time. Okay. All right. Let me get 2 laptops. Connect them quickly. This I will make 2 connections, FS01 and FS02, and the remaining will be FS03 connected to the laptops. Same scenario, but now we will explore the STP a bit. Let me name it again, simple, 1.1.1.1, and this is 1.1.1.2. Okay, this one I will like to rename the switch to SW1. Okay. Somehow the interfaces are not coming up. And this will be SW2. Let me just zoom this. Okay. All right. Again, you will see that the STP is turned on, and that's why one of the link is blocked port and the top link is working. So one link is working and one is down. That's actually the STP, how it functions. So if I go to my 1.1 and if I try to ping the 1.2, will that work out? Have I given the proper configurations here? No, I have not given it. One sec. 1.1, and let me quickly give it to 1.2 as well. Okay, we are done. Let me try to ping now. And let's see if that works. Ping 1.1.1.2. That works, right? There is no problem at all. So with the STP on, the ping absolutely works. Okay, now I would like to check how is the STP showing up there, like which switch is the root switch and which is having the root port and so on, and how the ports are there, like forwarding or blocking. So let me go to the switch 1 and quickly. Okay, if you want to view your spanning tree details, the command is do show spanning tree. That's all. Press enter and you will see the spanning tree. You will see that first of all, it is showing like IEEE, which is 802.1d. Okay. The second is that this is actually your root ID and this is your bridge ID. The bridge ID is the one which is the local one. And you will also see your cost is 19. It's a FE channel, or the link is 100 Mbps. Your hello time or the BPDUs is this one. Your max age is showing up, okay, which is from the disabled state, and your forward delay, like your listening and your learning, will be 15 seconds. Now, these are the 3 ports here, 1, 2, 3. If you go to switch 1, it's actually having 3 ports, 1, 2, and 3. The third is the laptop one. And let's see that the laptop one is the designated port, okay? And the first and the second, so the first one is the root port, okay? And the second one is your blocked port, port number 2. That is the port number 2. Okay, let me do one thing. Since this is not the root bridge, like we know the root bridge, how do we find it? We calculate the MAC address plus the bridge priority, right? And the bridge priority by default is 32768, right? So this is the 32768 showing up, and I will be just picking up this particular MAC address. And this one is your switch 1, so I will just give the name here, SW1, and done. So let me just keep the MAC address here for reference. Okay, now I need to go to SW2 and check out what is the STP details here. So here it is. Quickly enable config T, do show spanning tree, and you will see here this bridge is the root bridge. We'll check why it is like that, and we will take up this address here. That is the MAC address showing up here for the the root MAC address. This is the bridge, which is the local one. So our root MAC address is this one, which is showing up right here. And interface wise, again, 1, 2, 3 is there. One is, and all the 3 are showing in the forward status. 1, 2, and 3, all of them. Okay, and all the 3 are designated ports. So let me go ahead and put this MAC address here. Okay, now let's have a comparison with the MAC address, which is the least one, because like I said, the bridge priority is by default same for all the switches. Now MAC address, you will see this is 004 and this is 009. So of course the 004 is the least one. That's why the switch 2 is shown as the root switch or the root bridge. Okay, so that's the detail of this. Now we are going to play a little bit and we will check that how the shutdown and the no shutdown work. So basically how the timers work. So first of all, I will do one thing. I will go to my this laptop 1.1.1 and I will give a ping command which is called ping and then say -t, which means that the ping will be a continuous ping without any stop. I will say 1.1.1.2 and press enter. So ping is happening. Great. Now we'll come here and we will disable the root port. Okay, so let's see where is the root port now, because your root port should be FA01. FA01 is the root port in switch 1, right? And FA01, if I disable it, then as per the rules of STP, your bottom link should be turning up because your first link is gone. So let me just quickly take a little bit annotation here. Let's say your this link is gone, then basically it means as per STP that your bottom link should be turned up, right? That's how it works, right? So now let's have a check on how it is doing that. And we will go to your root port in SAW1 and we'll say interface FA0/1, that is your root port, and we will say shutdown, simple. Okay, press enter and the port is shut down. You will see the port is shut down. It will come with ambers now, but here this particular link is not up yet, right? Let me just go back and check it in the switch 2, what's going on there. Do show spanning tree, and you will see your FA02 is forward and 3 is forward, but what's happening to the FA01? That is gone, right? Now if I come back to switch 1, let's see what is the status here and what happened to your ping. Ping also will check right now. Ping is, see, the ping got timed out. It came up back again for a few moments. That's called the 30-second timeline. And if I go to SW1, let me quickly go there and let us see what is the new status. Do show spanning tree, and you will see your 3 is 90. I mean 3 is the forward and 2 is the forward. Okay, now it came up. So it took some little bit of time, right? Close to 30 seconds to come up. It was not coming up in the beginning, and that's why your ping was showing the request timed out for few seconds, right? Not few, like close to 30 seconds. Okay, now I will do the same thing again. What I will do is that I will go back to your SW1, and there I will say no shutdown. Okay, so first we say shutdown, and then we say no shutdown for the FA01. Press enter. Will it immediately come up? FA01? No, it's not yet coming up. See, if I just let's go back to spanning. FA01 is in the listening mode. The first one is the listening mode, right? And then and only then we can slowly get into our other stuff, which is your learning mode. So let's see. See, learning mode, right? And the last mode will be listening to learning to forwarding. So this is the forward mode, the last one. It got changed. Okay, so it takes time. It takes close to 30 seconds. Now imagine you're going to talk with your operations head of IT, and you are saying to him that if the first link fails, the second link will take like 30 seconds to turn up. Okay, will he or she accept that? No one will, right? Because in the business, 30 seconds of downtime in a critical situation is too high to accept. So that's when your solution of uplink fast and your backbone fast will be coming up. That you will learn in the CCNP when how to enable the uplink fast and the backbone fast for the trunk ports. Okay. Now I can show you right now the access port, which is covered in the CCNA level. So access port, I'm going to just take off this FA03 and show it to you. So if I go to FA03, let's go there, interface FA0/3, and I will say shutdown, right? If I say shutdown, your link goes down. What happened to your ping? your ping will also gone now. Okay, it's request timed out, so your FA03 link is down. Now let's say that I go back to switch 1 and say no shutdown. Okay, in the meanwhile I also check what is happening here with your do show. It is still in the FA03, still in the listening mode. And has your link came up? No, it is still in amber here, right? So I have to again see if it's coming to the learning mode. See, now it came to the learning mode, LRN, right? And it will take some time to come to the forwarding mode. Not yet. Not yet. It's taking time. Like I said, yeah, now it should be coming and it's forward mode now. So it takes some time, right? So 30 seconds again from your listening to forwarding mode. Now here comes the concept of the port fast command. Port fast command will ensure that it will completely bypass from your blocking state to your forwarding state. It will not go through the listening and the learning. So you will save complete 30 seconds time there. Let's see how we do that. So first of all, we have to be in the same port where we are going to do the port fast command. And number two, just remember that port fast command can only be used for the access ports, not for the trunk ports. Do not ever use a port fast for switch and switch connectivity or switch and router connectivity and so on. Okay, it is only for the access ports. For trunk ports, we are going to use the uplink and the backbone fast that we are going to check out in the CCNP. So here it is. I will just say spanning tree, and I will say question mark, and I will say port fast, right? That's your command here. Press enter. It says me incomplete command. Why? Because port fast, we have to go for the options. Let's go for this as well. BPDU guard. So we are not in the very correct command. If you try to do it on the switch itself, like I said, your port fast command has to be done on that particular access port. You cannot do it on the whole switch at one shot. Okay, so port fast is for the access port, and if you want to do for the trunk ports, you have to go for the backbone or the uplink fast commands. Okay, so I will go to interface FA0/3, which is right here. Press enter, and then I say spanning tree port fast. Enter. It's done. Once the port fast is enabled, then I will say shut down and enter. So the link is shut down, right? And what happens to your ping command? Your ping also is getting into request timed out. Fine. Now I will go there and I will just say that no shutdown. So no shutdown, enter. And see, immediately the link comes up. Okay, it bypasses the listening and the learning state. If you go to your ping, it got timed out the first time when I manually showed you. I mean, when we took off the link, but the next time, the moment we press, no shutdown, it immediately came up. So that is the beauty of the port fast command. Now, last thing about the spanning tree protocol in the rapid or the rapid spanning tree protocol, which is the next version of the spanning tree. And the beauty of the rapid spanning tree is that if you enable it on the switches, you really don't have to bother much about your port fast and other commands, because it automatically takes care of the conversions in a very faster way. So let's see. I'll go to switch 1 and I will just let me just take off this annotations. Okay, done. Cool. All right. Now on this one, on the switch 1, I will be going to spanning tree. I will say mode and I will say rapid PVST. Press enter. Done. And similarly, you have to do the same command on the SW2, which is spanning tree mode rapid PVST, right? Enter. And we are done. Now, if you get into this particular switch, let's see how it looks like. If I go and let's say do show spanning tree, you will see The IEEE got changed to RSTP, which is the protocol 802.1W. And here all the other things, like how the cost or how the other ports, the designations, they all are same here. Okay, the only good stuff is that if I take you to this, let me just go ahead and go to root port interface FS01. Okay, and I will say shutdown. Okay, done. Once I say shutdown, then immediately the rule is that your next link should be coming up. Okay, I think I did that without showing you the diagram. I will just do it like this. Interface. Okay, I will say no shutdown here. First of all, we'll check how the diagram looks like. So right now your FS01 is the active link, right? And the below one, the FS02, is the link which is down, which has got that amber color. So STP says that if I take off this first link, the active link, the standby link should be coming up. In normal STP, it takes like 30 seconds, but in Rapid, it tells that if I cut the active link, the standby link should be immediately coming up. So now the active link is FS01. Let's say that I deactivate that, then we will check that if the FS02 is coming up immediately or not. Okay, so once again, interface FS01, and I go and say shut down. Okay, press enter. You will see immediately your FS02 has came up, right? And if you look into the ping command, you will actually see there is no no kind of disturbance on the ping at all. The connectivity stays the same. So the end user will not even realize on the backend that one switch or one link got flapped and the standby is working, because the convergence time is almost close to 0. Okay, so that is the beauty of rapid PVST. All right, so with that we end the lab series of spanning tree protocol. Like I said, don't worry too much about the data shown in the first slide. I know it's too much, but I hope you got the concept. This is the concept of spanning tree, and just practice it once or twice. Just try to understand the selection of the root bridge, and the designated ports, the forwarding ports, how the blocked ports comes into picture, and why at all do we need spanning tree, and then things will be clearer. So right now by default, all the switches will be having spanning tree by default active on them. Even Rapid will be active on most of the latest switches, but if it's not, you can have a check on them by doing a do show spanning tree, and then you can take the call that you want to make a rapid PVST on them. Okay, all right, thank you very much. Thanks you for watching the video. Cheers. All right, welcome to the lab session of Etherchannel. So let's have a look into what Etherchannel is, and then we are going to configure Etherchannel. So let me pull out 2 switches and give them some multiple links. So this is FS01, FS02, FS03, and FS04. Okay. Now let me just go ahead and zoom this. Okay. Now, if you look into this 4 links which I've added between both the switches, though we have got 4 links, if you have just came out of the STP training, you will know that the spanning tree protocol will not allow all these 4 links to be active at the same time, right? If you look at the right hand side, you will see only 1 link, okay, is active, and the remaining 3 are standby. Because if you want to make all of them active, then again, your layer 2 broadcast storm will happen and your entire network will go down. right? So spanning tree does a good job, but the con of spanning tree is that if you want to make only one link as active and the remaining as standby, then you lose out on the advantage of the bandwidth of links, right? You may be having 100 Mbps on each of the links, and you lose out on 400 versus only 100 Mbps at any one point of time. So ether channel is the concept which will solve this. Now ether channel, if I want to define, then I will say, let me quickly grab a, yeah, ether channel will be your, is the aggregation, okay, of similar links into one single logical link, right? It will aggregate all these links into one single logical link as bundling all the links into one single logical link. Now the benefit of that will be, number one, of course, the bandwidth will be consolidated. So if you have got 100, links, combined link will give you the plus point of having 400 Mbps at one shot. Okay. Secondly, of course, since all the four links are working, and if any one goes down, then also your traffic will flow. So you're getting redundancy. And thirdly, since all the links are working like together, okay, you are also going to get the benefit of load balancing. So these are the tremendous benefits of ether channel. Now ether channel, it normally happens in two ways. One is your layer 2 ether channel and one is layer 3 ether channel. All right. Now layer 2 ether channel is normally used for the access layer switches, and layer 3 is normally used for your core layer switches. Now when to use what and why do we use a layer 2 channel for, I mean a layer 2 ether channel for access layer and a layer 3 for the core layer, that you will get the deep dive on CCNP level. Okay. Now a couple of things. Once these four links are combined, okay, these four links, then you will be having something called a logical port or a port channel. So you will name the links into one single link, you will consolidate them logically, and in the switch they will be represented as one single logical port. That's called the port channel. Okay, and that is in layer 2. But in the layer 2, you will not be able to assign any IP address to the port channel because it's a layer 2, right? It will not understand what is IP address. So in layer 3 ether channel, which I will show you again, in that one, you will be able to configure IP address to your port channel, and you can represent that IP, and through that IP, you can get connectivity to the other switch. Okay. Now, the other point which I want to talk about is the protocol. The protocol used for the ether channel is LSCP. We used to have PAGP in the past, but now PAGP is completely deprecated in the CCNA syllabus, and now it's only one single protocol, that is LSCP. Okay, so we are going to configure the ether channel both for the layer 2 and layer 3, and I will show you how to configure it, and then also I will show you how to verify your configuration. So let's start off. Let me clear the notes here. Okay, our first step will be to straight away go to the switch, and we will start configuring that. Before that, let me take away the bottom toolbar. Okay, now that's my switch 1. Let me go there, and on that, pretty simple. What I have to do is that I have to combine all these links. So basically I have to get into the interface range of all the links. So interface range, and I will say FS0/124 because there are, sorry, 1 to 4, there are 4 links here, right? FS0 1 to 4. So FS0 1 to 4, press enter. And once I get into the interface of the 4 links, I will type in only one single command to turn up the ether channel layer 2, and that is channel group, okay, and give a number. That number will be a character between 1 to 48, so you can create up to 48. We'll create like 20, and then I will say mode. Now ether channel works in two ways. I mean, in both the switch, it can be either active active, like switch 1 and switch 2 is active active, or it can be active passive as well. Okay, so I will just keep it clean. If I see the options, it shows me active, auto, so on. I will just say active, and I'm done. Press enter, and your ether channel is created. The similar configuration I will do on the switch 2 as well. And okay, sorry. Okay, and then let me go ahead and get into interface range FA0/124, and I will say channel group. I can keep it any number which I want to. I will keep it 20, and then I will say mode active. Done. So my ether channel is created, and the links are down right now, but after some time they will be up. In the meanwhile, let me quickly check the verification commands for the ether channel. So that's all. The ether channel has been created. Pretty simple, right? Now, if I want to verify the ether channel, I will say do show ether channel, and it will be showing up here. And I will see the ether channel created is a layer 2. The maximum ports that I can bundle is 16, but I have bundled only 4. And it tells me the protocol used is LSCP. Great. That's a brief one, a sneak peek, right? The second one, I will go for the detailed ether channel, and that's called do show ether channel, ether channel summary. Press enter. You will get the detailed stuff here. It shows very nicely that your 20 has been created, and that is SU. SU stands for your S is layer 2, and your U is in use. Great, which is fine. Sometimes it will be showing like, I standalone or S suspended, which is not good, which means that's something wrong. Okay, but your SU means is great, it's working fine. And these are the 4 ports which are assigned to your channel, port 1 to 4, and they are all in the status of P, and P stands for in-port channel. So all is great, right? The other thing I want to show you is, let me just show you the switch ports. So I will say do show interface switch port. Okay. And this one, if I check the port numbers like port 1 to 4, you will still see that they are still configured as switch ports only. They have not turned into something else. They're clearly showing as switch ports, port 1, port 2, port 3, and all that. So all is same. It's just that we are creating a logical number for it, which is called 20, right? Now, if I just go back to my first switch, there, let me check it up quickly. Let me change the switch name to SW1, and then if I just check it up, do show ether summary, and it clearly shows it is 20 SU, and SU is layer 2, right? And all is fine. Now, if I want to assign an IP address, now how do I do that? I can go to interface. I will say port channel, which is basically the logical channel, and I will say number is 20. Press enter. I'll try to add an IP 1.1.1.1 and 255.0.0.0. Enter. It will not take it. Why? Because the ether channel is a layer 2, and the layer 2, it will not understand or let you configure any IP address on that. So that's what about your ether channel layer 2 is, and you will see that all your links are now active. None of them is standby or disabled. That's brilliant, right? Because all the links are working, and you have just combined the power of 4 links into one single link. So that's about layer 2. Now let's go for layer 3. Now layer 3, we can also create a new topology, but I think we can do it right here. It's a layer 3 switch we have taken, and we normally will not go on top of it, because remember, if you want to create a layer 3 ether channel, then your layer 2 information must be deleted from the switch. So what we'll do here is that we can just reload the switch, do reload, and we'll say, do you want to save the configuration? No, and say confirm. It will reload in some time. Similarly, the link is down, of course, now, and I will go for the switch 2, and let me say do reload. Okay, no, confirm, right? So both are kind of getting reloaded. In the meanwhile, let me come back to switch 1 and see where is the status of reloading. Okay, reloading is done, it seems. Press enter, enable PT, and I will give a host name here, SW1, right? Now, again, if I want to go for the layer 3, the commands will be same. Only one additional command will be there for layer 3 Ether channel. So first one is of course the same, interface range, FA0/124. So you're going into the 4 links at one time, press enter. Now, if you want to convert your switch port L2 links to L3 links, all you have to do is that you have to turn off your switch ports. You have to say the command is called no switch port. If you give no switch port, automatically your switch ports will be down and they will be converted to L3. Press enter. All the links are down, right? And then your next command will be the same like what you did for the L2. So you will say channel group, okay, and you will give a number, let's say 40 this time, mode active, right? Done. That's about your SW1. Let's do the same for your SW2. Okay, SW2, and there I will be going into interface range FA0/124, correct? And I will say no switch port, enter, and then I will go for channel group 40, mode active, enter. So we are done. Let me check in this switch one first of all, where we are with the Ether channel summary. So exit, do show Ether channel summary, and let's see, it is showing us PO40, PO40, that is a port channel 40, RU. RU is layer 3, awesome, and U is in use, right, which is very good. And your links are 1, 2, 3, 4, all are in P, which is in port channel. You can also check it up your do show Ether channel, and you will see your state has been changed to L3, right? Uh, Similarly, if you check the switch ports, do show interface switch port, you will see one nice thing there, and that is your ports are starting from port 5 onwards, because 1 to 4 we have converted, or we have taken off the switch ports there, right? And they have been converted to the IP. So or the L3. So the switch ports are gone. So your port summary is showing from F5, and 1 to 4 is not showing here. F5, and then you see F6 and so on, F7. Okay, so like that. Right. Similarly, let's check our S2. So do show. Sometimes your packet tracer may not give you the correct information once you reload the switches. So it's good to verify at both the ends to make sure that it's been converted to L3, right? So do show Ether channel, and it is converted to L3, of course. Do show Ether channel summary, and it is showing all in use. LSCP is coming up, great, awesome. So we are good. Now, if I go to SW1, let me see that if I can configure an IP address on the port channel. So I will do something, interface port channel 40, right? And I will say IP address 1.1.1.1 and 255.0.0.0. Okay, enter. It took it, right? Similarly, for SW2, I will configure the IP. Interface, port channel, 40, IP address, 1.1.1.2, and this is 255.0.0.0. Enter. It took it, right? Now let's see if we can ping from switch 2 to switch 1. I will say do ping 1.1.1.1. Press enter. And you can ping it, right? It comes absolutely fine. So that is the layer 3 Ether channel which I wanted to show. And again, you see all the links are up and running. It's working beautifully. Okay, so that's all about the Ether channel, and that's about the L2 and L3. And L3, like I said, we will be taking a deep dive in our CCNP sessions. Thanks a lot. Thank you for watching the recording. Have a good time. Cheers.